All right, welcome everyone to week 3. If I could have everyone's attention, please. Unfortunately, Ishan won't be able to join us from this week onwards, scheduling conflicts, but I'll try to monitor both the chat area and Menti slides where we can post questions, and hopefully it will all work out. There's only one question right now, and it's not really relevant to the class, but we still haven't figured out who will do the Friday 3 p.m. seminars. If there's nobody there and I'm still up and kicking, I will definitely do the Friday 3 p.m. seminars. Otherwise, I'll try to arrange some other form of. Yeah, we'll make sure that everyone does have a seminar to attend. Now, the Menti code for today is 63 16 19 91. Throughout the class, if you need to ask a question, please go to menti.com. I'll bring this slide up again, and you can post them over there. Now, I don't know if you've seen this yet, but our first assignment is out. I hope you do get a chance to have a look at the assignment instructions and the data. Everyone, if I could have your attention, please. If you could settle down, we'll continue with the class. Just a note on the assignment, you will need to spend a bit of time understanding the data and the variables. We have several support resources for the seminars. As pointed out over here, we have our discussion forums for more general stuff, and then we have consultation sessions. 2 additional ones, one-off additional ones have been booked for Tuesdays. We also have the regular past sessions on Mondays. I'm hoping many of you are attending those. They're really helpful. And yeah, that's pretty much it. With what you've gone through in week 2, what you will see in your week 3 seminars, and also some of the stuff from week 4 where we focus on creating a dashboard, all of that together is going to help you work on your first assignment and prepare that dashboard for submission. I'll start over here because last week we didn't get to finish our class looking at univariate analysis. There's not a lot to it, so we'll get through this very quickly, and then we can move on to bivariate analysis, which will be the focus of today's class. With univariate analysis, what we were looking at were, first of all, figuring out what type of variable we're interested in. Is it a categorical variable or a numeric one? If it's a numeric one, you take certain approaches to explore that variable and to come up with a summary of what it represents, looking at stuff like central tendency measures, looking at dispersion measures like variance, standard deviation, that sort of thing. And we got to this point where we were looking at shape measures. And everyone in the back hear me okay? Perfect, thank you, thanks. If it were categorical, we'd be more interested in frequencies and proportions. Again, depending on the variable type, we'd be looking at various forms of visualization. So for instance, if you're interested in a categorical variable, you might attempt to visualize the data using a pie chart or a column chart. If you're dealing with a numeric variable, you probably would go for a box plot to look at those central tendency measures like mean and things like first quartile and third quartile that look at more location type of measures. And there's also the histograms that you can create for a single numeric variable. looking at the distribution of the values of that particular variable. Now, focusing more on measures of shape, there are two measures that we're interested in, skewness and kurtosis. You have definitely talked about skewness in your week 2 seminars, because this is how we figure out which approach to take to deal with outliers. But we're just going to quickly recap, and again, you'll get practice looking at this in your week 3 seminars. So what is skewness? Skewness essentially allows us to think of a variable, a numeric variable, and its shape being symmetrical or not. That's what skewness does. These are the 3 possibilities for the distribution of a numeric variable. It's either symmetrical, which is the image you see on the left-hand side, where usually the mean, median, and mode either overlap or are very close to one another. Then you have the image in the middle, a different kind of distribution. This is called negatively skewed distribution or left skewed, where, as you can see, and it's clear from the image, the median is larger than the mean. Ultimately, you have the one on the right called positively skewed or right skewed. The mean in this case is larger than the mean. Now, your skewness coefficient, the value that you get for skewness, is going to help you figure out which form of distribution you're actually looking at. It is very rare that with real world data, you'd get a skewness of exactly 0. It's usually a little bit to the left or a little bit to the right. We rarely get perfect symmetrical shapes, and that's okay because we kind of approximate anyway. So what I'm getting at is if you calculate the skewness coefficient for a numeric variable, and the skewness coefficient turns up to be -0.3 or positive 0.3 or something to that effect, you kind of say, this is approximately normally distributed, and you consider that to be a normal distribution. Usually when you get something higher than 0.1 or lower than -1, that's when you kind of say, this isn't symmetrical, so I have to treat that particular variable a different way. Excuse me. All of that information is available. Like I said in last week's seminar, you've even used this to figure out which approach to take to outlier detection, and I'll briefly talk about that today as well. The next measure of shape is kurtosis. It's very similar to skewness because it's looking at the shape of the distribution of values of a numeric variable. The main difference is instead of looking at being skewed to the left or right, it's actually looking at how peaked the distribution is, or how flat, if you like, the distribution is. There are 3 forms. Don't worry about the names. No one's going to test you on these. But it just essentially means whether or not most of the values of a particular variable are close to the mean. If they're all or the majority of them are close to the mean, you get a very peaked distribution. If they are all spread out away from the mean, you get more of a flat distribution. And then you have the mesokurtic, which is normal distribution. We don't really use kurtosis figures in MIS 171, but we would like you to at least have heard of it moving forward. Now, going back to our discussion about our discussion about outliers. In MIS 171, we take one of 2 approaches in dealing with outliers. We either use the empirical rule or Tukey's rule. The one we choose depends on the skewness coefficient value. If the skewness coefficient value is greater than 1 or less than -1, we consider the distribution of that variable to be not symmetrical, and therefore we use Tukey's rule. If it is between -1 and 1, then we decide to use the empirical rule, considering that the distribution of that variable is almost normal. Now, how you go about using empirical rule and Tukey's rule, that's what you should have discussed in week 2 seminars. You'll repeat that in week 3 as well. Essentially, it means if it's symmetrical, you consider values that are 3 standard deviations away from your mean as extreme. Why do we consider this rule? Why do we consider the empirical rule? If I go back a few slides and show you this image from week 2, you'll see that we were saying if the distribution of the values of a variable are normally distributed, we have something called the empirical rule, which allows us to say 68% of all the values of that variable fall between mean plus minus 1 standard deviation. Then we said 95% fall between the mean plus minus 2 standard deviations, and 99.7% of all the values fall between mean plus minus 3 standard deviations. So if you consider a variable and all its values, let's say core 4 scores for the Vic-versity case, and you come to understand that the core 4 scores are normally distributed, you can essentially say, and you can double check this, that 99.7% of students who took core 4 got grades 3 standard deviations plus minus away from the mean of core 4. And only 0.3% of students got values outside of that range. You can double check this if you like. And this applies to essentially all variables that are normally, all numeric variables that are normally distributed. 0.3% is a very low number, and that's why we call this extreme. That's why we call this an outlier. So I'll give you an example. Everyone in MIS 171 gets a final grade between 50 and 70, everyone, except for 2 students. One student gets a 0, another student gets 100. When everyone is getting a score between 50 and 70, and you have those 2 exceptions that are so far away from the mean, which would be around 60-ish, you consider those as extreme values, as outliers. And then you would investigate what's going on. Is that person who's received 100 a genius, or have they done this before, or have they cheated, whatever? And then you would go and look at the person who's received a score of 0 and figure out what's going on. Do they need more support? Did they even attend the class, or was there an error in data entry, including them in the unit where they were never meant to be enrolled? That's one approach. If it's not symmetrical, so when you look at the skewness coefficient and the shape of the distribution is skewed one way or the other, then you cannot use this empirical rule. You have to use a different approach. In our unit, we're asking you to use Tukey's rule. And with Tukey's rule, it essentially says, look at the first quartile, take away 1.5 IQR, or the interquartile range. That will be your lower fence or lower limit. And look at Q3, third quartile, add to it 1.5 IQR, that would be your upper limit. Anything outside of that range will be considered as an extreme value or an outlier. I'm pretty sure that every tutor has made a point to mention this. Sometimes some software platforms identify their own outliers based on their own approaches. For instance, in Excel, there's a different algorithm to calculating and identifying outliers. And if you use a box plot to look at those values, you might find certain data points outside of those whiskers. That's not what we consider as outliers in this unit. I'm sure that your Tutors will reiterate this in week 3 again. Are we comfortable with the description of outliers and what it means to our data points? Going back over here. I'll come back to those questions, but right now, any questions about skewness, coefficient, kurtosis, and or outliers? Online students over here. Nope, we're good. One more thing about outliers. It's not always a bad thing to be an outlier, to be an extreme value. Like I said, with core 4, sometimes you may find one student who's doing really, really well, who's getting the only 100, the only HD. And you can potentially approach that student to help. In the case of Hannah, she is now your past leader. So the team approached her to be the past leader because of how well she ultimately did in MIS 171. So it's not always about saying, this was an issue with the data. Cool. So if there are no questions, I'll move on to week 3's content now. With the 2 that are coming up here, I'll come back to them at the end of the class because they're not related. What are the benefits of kurtosis? Well, like I said, if you can figure out whether or not the distribution is peaked or flat, you can start thinking more closely about the spread of your data. The example I gave was if everyone's got a core 4 score of 50 compared to when you have a completely spread out, people getting 0s, 10s, 20s, 30s, all the way to 80, 90, 100s. The way it's spread out is different, so the way you would treat it would be different in your analyses. Can you explain outliers? Yes, so within an organization, if you're interested to identify top talent, those really, really high achievers, you would try to look at performance reviews and consider who's getting the highest performance reviews, and those could potentially be outliers. If you're looking at, consider manufacturing. With a manufacturing line, it's not that every product that comes out is faulty, right? There are certain exceptions, and those exceptions could be treated as outliers. So someone who's doing quality controls will look at the output and try to realize what's happening with those instances where there is a fault with the product, which are outliers, but that will assist them in improving the overall line. That's another way to look at it, outliers. But like I said, with university stuff as well, how much more support you can provide to those outliers? Are there circumstances totally different to everyone else, et cetera, et cetera? It doesn't have to be completely symmetrical. So don't think that the coefficient of skewness needs to be exactly 0. That pretty much never happens in reality. As long as the coefficient of skewness is between -1 and 1, you can consider that as relatively symmetrical and therefore use the empirical rule moving forward. So one looks at how peaked or flat is, the distribution is. The other one looks at to which side does the shape go. So are there more high achievers? I'm looking at core 4. Do we have, think about the distribution of core 4. The results that you can get in MIS 171 are vary between 0 and 100, right? Now, if it's totally symmetrical, you'll have the same number of zeros as you have 100s, the same number of 10s as you have 90s, the same number of 20s as you have 80s, the same number of 30s as you have 70s, et cetera, et cetera. And the most frequent value would be 50 for everyone, right? After that, the most frequent will be both 60 and 40. After that, the most frequent would be 30 and 70, et cetera, et cetera. That would be a perfect symmetrical shape. Now, with that, let's assume that you still get an average value of 50, but there's a lot more people getting distinction and high distinction. Then you will have skewness in your data. It will not be symmetrical. A different cohort, a different year. Let's say it's the pandemic again, people don't really care about studying for MIS 171. Then you would have a different form of skewness. Maybe most of the grades will fall below 50. All right, let's move on to week 3. I'll come back to the questions after the class. As we just briefly talked about, and also back in week 2, univariate analysis focuses on a single variable. You only look at one variable and try to summarize whatever you can about that one variable. Bivariate analysis then takes that a step further and says, okay, how about let's look at 2 variables side by side. Let's look at the relationship between 2 variables. If you wanted to do that, you'd have to consider the variable types first. From a higher perspective, we only have 2 types of variables. We either have categorical variables, like fruit names, or the grades we get in MIS 171 being HDD, credit and pass. From the other type of attribute that we can have are numeric ones, so value, numbers, essentially. If you're looking at 2 variables and looking at the relationship between those 2, there are 3 pairwise relationships that you can imagine. Either both of your variables are categorical, or both of them are numeric, or one is numeric and one is categorical. There's no other option, right? So we get 3 options. 1 categorical, 1 numeric, 2 numerics, or lastly, 2 categorical variables. And we have to first realize which approach is going to help us understand the relationship a little bit better, and then follow the required steps. That's bivariate analysis for us. With the scenario where you're looking at 1 numeric variable and 1 categorical variable, you usually use comparative summary measures. You'll practice doing all 3 in your seminars this week, but comparative summary measures, I think, is going to probably be the easiest one for you because you've already seen this happen in week 2. The only difference is you have to do it multiple times. So what I'm getting at is in week 2, you looked at a single numeric variable like performance, and you attempted to summarize performance from different perspectives, looking at central tendency measures, looking at dispersion measures, and shape. Also trying to identify outliers, etc. The main difference here is that you will be separating based on the categorical values. What do I mean by this? So imagine we're looking at MIS 171 or Core 4 scores in Vicversity. Now imagine we separate. Initially, we can look at all the students, put everyone in the same group, and look at performance in general. Find the mean, the median, the mode, Q1, Q3, IQR, look at outliers, et cetera, et cetera. If you wanted to take this a step further and look at 2 variables at once, you may be interested in looking at origin, or domestic versus international. And what you could do is you can separate all the domestic ones from the international students and look at the mean of Core 4 for all domestic students, compare that with the mean of core 4 for all international students. See if there's a discrepancy, or are the two cohorts behaving the same way? Since origin, domestic versus international, is considered a categorical, and core 4 scores is considered a numeric, this is bivariate analysis, looking at two variables at once. And that comparison is going to allow you to say, maybe we need to provide more support to domestic students or international students, whichever, depending on the values you get. Or you may find that both cohorts behave the same way. Both of them are getting the same mean, the same standard deviation, the same sum, if that makes sense for core 4, et cetera, et cetera. After this, we'll come back and look at categorical versus categorical. So comparative summary measures. With your desk place case, you looked at performance in week 2, but you looked at all employees. This time around in week 3, you'd be separating them. For instance, looking at the performance of all management employees versus the performance of all non-management employees. Make that comparison looking at mean, skewness values, standard deviation, et cetera, et cetera. And this is what it would look like. So if you calculated the summary measures, those values of skewness, kurtosis, standard deviation, mean, et cetera, just for core 4, and considering all students in VicVersity in the VicVersity sample, you would draw a box plot or a histogram to look at distributions for them. Now, if you consider gender or origin or whatever, then you can separate and look at different cohorts separately. Now, I mentioned this in week 1. I have to reiterate this. This is a fake case, and the data is not really representative. Apparently, there's only 3 possibilities, male, female, or prefer not to say for gender. Please don't read too much into that. It's an old data set that they've used, and obviously there's a lot more options that should have been there. And hopefully they will fix this moving forward. But if you drew the distribution, asked for a histogram to look at the distribution of all VicVersity students, compare that with all female, let's look at origin instead. All VicVersity students, only domestic VicVersity students, only international VicVersity students. You can see how the distributions of those would be different or similar, and then talk about what needs to be done with regards to decisions. You can also separate each of them and look at them separately as well. With multiple box plots, you can see them side by side. So values of central tendency like mean, values of location like Q1, Q3, median, that sort of thing can be represented in the multiple box plot, separating the categories. So one color, let's say yellow, could represent international students, blue could represent domestic students, and green could be the whole entire cohort, everyone put together. Any questions before we move on to the second form of relationship? Wow, there's a lot. Yes, so if skewness is between -1 and 1, we use the empirical rule. Anything outside of that range, for instance, a -3 skewness coefficient would mean we'd use Tukey's rule. All of the questions seem to be about skewness and kurtosis. Okay, we'll come back to this. Any questions about comparative summary measures? Like I said, I think it's pretty straightforward because you've done this on one variable, so separating isn't going to be much of an issue. All right, let's look at crosstabs. So how can we go about comparing when we're looking at two categorical variables, how can we go about comparing the instances? The case uses gender and origin. Again, don't worry about the values too much. But in this particular case with Vicversity, there are 3 gender values, male, female, and other. And there are 2 origin values, international and domestic. And we want to see if there are any differences between the cohorts. Essentially, what we will be looking at is a simple count. Please only look at the top left table. We'll come back to the other ones in a second. Just looking at the top left table, what you see is considered a frequency cross-tabulation. It's essentially simply counting the number of students in each cohort. So with F, it refers to females. I refers to international. And the intersection, the number 85, tells us that with the Vicversity sample data that we have, there seems to be 85 female students who are also international. If I were to ask you how many students do we see in the Vicversity sample, what would you say? Overall, how many students? 500, very good. So Vicversity sample data has 500 students in it. Out of those 500, 85 of them are female and international. How many students are male and domestic? 175. It's pretty simple, right? It's a simple count based on the values of the 2 categorical variables that you're investigating. Now, the problem with frequencies is that sometimes the data set that you're looking at is not balanced. So you don't have the same number. What we mean by balanced is, or unbalanced, is do you have the same or similar numbers for each category or each class of values for your categorical variables? If you have the same number of international students and domestic students, you would consider this a balanced data set regarding origin. Now, if you look at the numbers, we only have 155 international students here compared to 345 domestic students. And that's a big gap. More than double domestic students in this data set. So regarding origin, you would consider this an unbalanced data set. A similar thing can be said when you look at the 3 gender values that are shown here. So 14 compared to the other 2, you wouldn't consider this a balanced data set. When you don't consider this a balanced data set, when you figure out that this is in fact not a balanced data set, then just using the crosstabs isn't going to be very helpful because you can't make meaningful comparisons between 6 and 175. Instead, we usually go for proportions. So instead of just looking at the count, we transform that into a proportion, either based on entire rows or based on entire columns, or based on overall, all of the data put together. And that's why you have 4 tables here. The table on the right, top right-hand side, the, I think, purple one, is looking at all internationals versus all domestic students. So it's taking a percentage. The percentages that you see is based on either being entirely international or being entirely domestic. The one in green, bottom left-hand side, is focusing on gender values. And the one in blue represents the numbers in proportion to overall 500 students that we have in this data set. I'll give you an example. Look at 12.8%. I'm referring to the green table, bottom left-hand side, and I'm looking at male international intersection, 12.8%. What does that mean, the 12.8%? It means that out of 500 students in the Vicversity case, out of 500 students in the Vicversity case, 12.8% are males and international. That's a proportion out of total Vicversity students. Now, if I look at the purple one and look at the same value for the intersection of M and I see the value 41.3%. That 41.3% means that out of all international students, 41.3% of them are males. Does that make sense? Let's go for another one. What percentage of domestic students are female in this sample data set? Shout out the answer once you've calculated it. What percentage of domestic students are female? Online students, you can also use the chat area. You have to speak a little louder for me to hear. I heard someone say something, but what percentage of domestic students are females? 47%. When the question is referring to a percentage of one of the classes of one of your categorical variables, you have to look at either the purple one or the blue one. You should not be looking at yellow because yellow doesn't give us percentages anyway. And you should not be looking at the green one because it's looking at percentage overall. So between purple and blue, which one do we pick? My question was asking what percentage of domestic students or local students or L are female. With this, we can see that the values of origin, I and L, are placed in the rows. And that's the purple one gives us 100% as total at the end. That's how I know that I need to look at the purple one and not the blue one, which looks at columns as total percentages and gives me 100% for the columns. So with the purple one, what percentage of domestic students are females simply means look at the intersection between L and F, and the value that you see there gives you that percentage. There's a ton of questions that you can ask yourself and you can practice with this. And you can also look at each and every one of the values in these four tables and try to interpret those values, what they mean. So for instance, 34.4% down here, it essentially means 34.4% of all females are international. Down here, the intersection between F and I, 34.4% of all females are international. Yes, Jason, 47%. I hope that made sense. You'll do a little bit of practice on this in your week 3 seminars as well. It's a lot more challenging than this, but once you get the hang of it, you'll see that there's no big issue with this. Now, why did we do all of this? Why are we looking at those percentages? It's not just about being able to interpret each of the values in that table. What you essentially want to do, because it's about bivariate analysis and comparing the values of those categorical variables. If you can find a meaningful difference as you move across or you move down or up in the cells of those tables, if you find a meaningful difference, that's when you know that what you're looking at is different. There is not a perfect symmetry or perfect similarity between the values. So for instance, if this value over here, sorry, if this value over here, the 41.3%, if this were 70%, and then with local students, the value that you see for males was 10%, you'd see that as you move right from column F to column M, there is a huge change between international students and domestic students. And that will kind of indicate, these two cohorts are not behaving similarly when it comes to the numbers that are in our sample. But don't worry too much about this. You'll see how it works in your tutorials. You can also visualize this using simple column charts, as you've seen in week 2 as well. Now, the last form of relationship, when you have two, I forgot to expand this, when you have two numeric variables and you're trying to compare two numeric variables. For instance, with the Vicversity case, if you're looking at the number of tutorials or number of seminars that students attend versus the final grade that they get in Core 4. Looking at the relationship between these two can give decision makers a sense of, okay, if there is a proper positive relationship, and by that I mean if, for instance, you uncover that students who attend more seminars tend to get higher Core 4 scores, then maybe from 2024 onwards, they'll make attendance mandatory or something like that. So policymakers and decision makers can think about how what you uncover with the data that you have can affect their decisions. If they come to understand that higher attendance is ultimately going to result in higher grades, they might say, okay, from now on, everyone has to attend at least 5-6 seminars per trimester or whatever. So it's about looking at two numeric variables and comparing those two numeric variables. And that's what we have for the Vicversity case. Usually when you get something like this, you'll be able to also draw a trend line, a best fit line. We will see how this works in week 8, I believe. Just a quick explanation of what those green data points actually mean. If you look at TUT attendance 1, just TUT attendance 1, there's a lot of green circles when you just look at TUT attendance 1. That means that every person in the Vicversity sample who attended exactly one tutorial got a score in Core 4 between 45 and about 85. Many people attended a single tutorial. Some of them got 45, some of them got 50, some of them got 60, some of them got 70, and there was one apparently that got 85. So it's kind of mapping all the values when you look at two columns, two numeric columns side by side. It's like this. If you go to Vicversity and you look at attendance and you look at Core 4 and you say, take these two and sort them based on attendance. We've got a bunch of zeros, but we also have ones, and this is what you see for the ones, right? That scatter plot is showing us all the possible values for Core 4 for every single person who attended a single tutorial, and then every single person who attended exactly 2 tutorials, and then every single person who attended exactly 3 tutorials. Once you look at that image, that scatter plot, you can either identify a relationship between the two numeric variables or you can't. There's 5 possibilities. There's actually a lot more, but for you, there's 5 possibilities. These are those 5 possibilities. It's either spread all across the board. It's so messy, as is the image on the right-hand side, where you cannot fathom a relationship between the two numeric variables. Or what you see looks more like the image on the top left-hand side, the image at the bottom left-hand side, top right-hand side, or bottom right-hand side. If it's more related to, if what you're seeing, if the relationship between the two variables are more or less like the one in top left-hand side or bottom right-hand side, you consider those relationships as strong. Changing one really affects the other one. So if the relationship between your tutorial attendance and Core 4 scores looked like this one down here, the one bottom right-hand side, it would mean that the more tutorials you attend, the higher on average your Core 4 scores will be. If it were the top left-hand image, you'd say the more tutorials you'd attend, the less you would receive as your Core 4 score. And these other two, you can kind of identify a relationship between them, a linear relationship between them, but ultimately it becomes a judgment call. The more practice you get, the easier you will be at distinguishing that. But luckily, we don't just have to rely on scatter plots and images like this. We can also do and calculate a measure, a value, a number to help us assist in combination with looking at the images. You can use that value called the correlation coefficient to say, okay, there is a relationship or there isn't one. You will see how we calculate correlation coefficients in your seminars. It's essentially a measure of how connected, how related, how correlated two numeric variables are. The values range between -1 and 1. The closer to 0, it essentially says that there is no relationship. The scatter plot will be all over the place. And the closer to -1 or 1, the stronger the relationship between your two numeric variables. -1 reflects the inverse relationships. So all the -1s for your small r or correlation coefficient means inverse. And any positive value essentially means a direct positive relationship between the two. And that's pretty much it. Again, in your seminars this week, you will see how you can compare two numerics, two categoricals, one numeric, one categorical. Last week, you looked at univariate analysis and you attempted several visualizations. This week, you will also attempt several visualizations. Your first assignment is essentially asking you to bring all of those visualizations together, the most important key ones. Try to make it interactive. The interactivity is something we will work on next week, and present your findings as a dashboard. Please don't forget all the support and have fun. I'll see you again next week. Let me know if you have any questions. I'll bring up the Q&A Mentimeter stuff as well and try to go over them. Yes.
The correlation, like, because you know how the coefficients like -1 to 1. Is there a specific possible rule? Is there like any rule of thumb that I can use? Yeah.
In this week's seminar, we have a worksheet. If you look at the data, we have a worksheet that kind of plans out. If it's above 0.7 or below -0.7, we consider that as strong. And anything between 0.4 and 0.7, or negative 0.4 and negative 0.7 moderate.
Okay.
Below that, weak, blah, blah, blah. But there is a worksheet that,
Okay, yeah, I just wanted to rule of thumb here. Thanks.
again, it's subjective, right?
Yeah.
People take it differently, but yeah. So questions, let's see, let's go back. Hope I didn't miss anything. We did talk about this, and when do we use normal charts? If you have created a pivot table, depending on what you're attempting, you can usually get a pivot chart from it. But if you haven't created a pivot table, you would need to go for a normal chart. There are certain types of charts that you can't really use a pivot table or a pivot chart for. For instance, if you wanted to look at something like a box plot, you can't use a pivot table or pivot chart. It has to be something else. But a lot of the other ones, like for instance, a pie chart, you can get either way, either just looking at the data or using a pivot table and then getting a pivot chart off of it. Before I continue with the questions, there's someone over here. I'll help, and then I'll come back. Which one? I asked the tutor to gather everyone in there. We have 2 concurrent ones, and I couldn't come to uni, so I asked the tutor to come and grab everyone and take them to their class, the other tutor. We have 2 concurrent seminars at 1 p.m. One in 307, the other one in 309. It was so bad I couldn't get out of bed, so I just asked them to come and grab everyone. They may have missed you. Did you get there late? I have no idea. Yeah, I just couldn't type or do anything. I was like this on my bed, but I know that he did come to 309 and asked everyone to join them, because he called me afterwards and let me know that a lot of students from the 1 p.m. 309 session went over there. He may have just missed you. I'm sorry that happened. No, it shouldn't have happened last week. It was just, I was not well at all. I couldn't get out of bed to come. Yeah. Worst case scenario, I'll ask Ishan to put a note, and I'm lucky that we have 2 concurrent sessions. So if there's, I still haven't recovered, but if it's really bad, he will just note that 307, right behind our room, there's another one that you can attend. But I'm really sorry this happened. Hello, 17 questions left. There are no silly questions. We're here to learn and personally, I would start with the content. If I know why I should do something, I can then go and find out how. If I just know how to do something and don't know why I'm taking the steps that I'm taking, that's when other people are going to have like an advantage over me. And if you're thinking long term, so I'm not just doing this for the sake of the grade I'm getting in MIS 171, but I want to learn something that will help me in the future, then that's the way to go. So why? The how of it is Google search or ChatGPT or whatever. They can help me. So definitely start with the why we're doing things. And for instance, with univariate analysis, I would start with what does it mean? What do we mean by univariate analysis? And how is it different when we're looking at a numeric variable versus a categorical variable? And if we're looking at a numeric variable, what are we interested in? So central tendency measures like mean, median, blah, 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 versus the ones when we're looking at categorical frequency proportions. And then think about, okay, if I'm interested in frequency, how can I get frequency values? If I'm interested in mean, how can I get mean? And those will be the Excel steps that we practice in the seminar. Does that make sense? Yeah. And this wasn't a silly question. This was a really important fundamental question related to. Yes, yes. Yeah, yeah. Take it from me, with all units and everything that we learn at uni, it's more of a gradual. I'm going to put this here and then put another brick on top and another one on top. And at the end of the day, you'll see that you have a perfect wall. So it's a gradual. Don't. Yes, exactly, exactly.
Try not to use but there are some key if we just study the technique,
Yeah. Yes, yes, definitely. But it kind of build on. Exactly, exactly. Thank you. See you. How can I help? Yep. Yes, I've put out the week 4 content as well, the lecture class, but more importantly, the tutorial slides. You'll see in the tutorials that for it to be interactive, if you use pivot tables and then pivot charts, then you can add slicers and whatnot, filtering slicers. You can, there's a lot more steps to it. This is a lot more straightforward, but yes, you can. It's not gonna be as straightforward, is what I'm saying. Macs are different. Yes. Yeah, I know. I'm sorry. It's just that with Deakin, the policy is they expect everyone to use Windows. And they essentially say, if you're a Mac user, go out and figure stuff out on your own. That's the general policy. So if someone comes to us and says, I don't own a Windows-based system, we're told to say there's a ton of computers here, labs and whatnot that you can use. Now, having said that, if you do have a specific question, please do reach out using the discussion forum. Stephen, I hope that we'll get access to a Mac and he'll be able to test it out and see how it might work. The functionality is not. No, it is possible. It's definitely possible to do it in Mac. It would be different, yeah. And I totally understand why the past leader couldn't help because it's a different platform and they're used to using this. I've never used a Mac, so if you asked me, I'd spend an hour searching online to find a way. It is possible to find a way. It's just, yeah. There's I think with our entire unit, there's maybe 1 or 2 things that we say you can't do it on a Mac because the functionality it's just not there. But overall, everything else, it's doable. Yeah. You shouldn't be at a disadvantage. So you can get everything done on a Mac. No, it doesn't. It says interactive dashboard. That's all that is. With the assignment, I think I mentioned this in the instructions. Nobody's going to look at any of your worksheets except for the dashboard. So they'll open up and look at the dashboard, see how it works, try to interact with it, make sure that it works correctly as it's meant to be. And there's some points for, visual, are you using too many bright colors and all of that? Is it professional? That's what they see. They're not going to look at any of your other worksheets to see how you got to the dashboard. You're most welcome. Best of luck. And don't forget, if you have a question, ask us and we will try to help if we can. Yeah. You're welcome. See ya. Bye. So when do we use pivot charts and when do we use, I think we just talked about that. Is it possible that the assessment will be available with more time? Unfortunately, not 7th of August is our deadline, 8 p.m. There's some leniency for people who may submit after 8 p.m. until 11:59 p.m. of 7th of August, but that's the after that. If you don't have an extension, an approved extension, you will start to lose marks, unfortunately. We talked about this. Depends on the person. Some people may do it quicker, some people slower, but I wouldn't leave it for the last minute. Talked about this, yes. Talked about this, talked about this. Yeah, so the shape of the distribution will be different. I think we talked about this as well. So one would be skewed either left or right. The other one is more concerned with how peaked or flat the data is. So the conditions are, look at the skewness coefficient. If it's between -1 and 1, you use the empirical rule. I'm not sure where you're getting at. Kurtosis looks at a different thing. You can still consider kurtosis if it's not symmetrical. It looks at peakedness versus flatness. How to identify when to use Tukey's? I think we talked about this. So if your skewness is between -1 and 1, you use the empirical rule. If it's outside that range, you use Tukey's rule. Please refer to the week 2 seminar instructions, because this is also detailed over there. The online seminar link for last week should be under content, and then at the bottom, class recordings. And under here, seminar recordings. So this is the week 2 seminar recording. Week 3 seminar recording will be posted here at the end of the week. Week 4 will be posted at the end of week 4, et cetera, et cetera. So usually on the Friday. Do we need to know the additional visualizations that we, in the end of, it's just for your own benefit if you'd like to. We'll come back to visualizations next week, because next week is all about visualizations and dashboards. No, you do not need to know any formulas. As long as you know how to get to the correlation coefficient, that's what matters. And even if you forget, you can look it up online or use your textbook or use your class slides to figure out how, or seminar slides to figure out how to do this. But you don't need to memorize anything. All right, that's it. Thank you very much. And yeah, I'll stop the recording now. Oh, I didn't realize we still have 5 students online. If you have any further questions, please let me know.